Hello everyone! So today is part 2 of acids and bases, and this is all about neutralization. So let's get into it. Generally speaking, our learning goals are to be able to write the chemical name of different acids. There are 2 different acids. We have binary acids. Remember, bi means 2. So there's 2 parts to the acid. And oxy acids, well, oxy is like oxygen, so basically it has oxygen in it somewhere. And then bases, you actually already know how to name bases, so that's pretty cool. Good job. You also will need to know how to write the chemical formula of acids. So that's similar to the chemical name. Again, we have binary, oxy, and, well, bases. Again, you already know. Well done! We're partway there. How to be able to recognize a neutralization reaction and be able to predict the products, and those go hand in hand together. So naming binary acids is pretty easy. Basically, when we have a binary acid, we have a hydrogen and we have some other, so our base is hydro something ic acids. And all you're going to do is whatever that atom is, you're going to replace it in that space. So hydrogen and sulfur become hydrosulfuric acid. And so you have to notice the ic. In ionic compounds, we added the subscript "ide". This time we're adding ic. So hydrochloric acid is one that you're very familiar with. So hydro, the name of the atom, ic, and then you just throw an acid on it at the end. Why don't you pause the video and give some a try? Okay, I'm going to assume you paused it. What this gives us is hydrofluoric acid, hydrobromic acid, and hydroiodic acid. And there they are. Fairly straightforward, I think. We have a second type of acid. So the one before that were binary acids. These are oxy acids. So the oxy acids have an oxygen. Usually you'll see them with a polyatomic ion. Writing these acids are a little bit more complicated. So the instructions say to write the name of an anion. Remember from our very first discussion in chemistry, anions are ions that are negatively charged. So in this case, that would most likely be our polyatomic ion. Well, definitely would be a polyatomic ion. So you're going to write the polyatomic ion, and let me grab my periodic table and polyatomic ions list. So carbonate is the one that I am looking for. And so you remember that carbonate is CO, let me just fix that, CO3, and it's minus. Nope, 2 minus. There we go. And so I'm going to rewrite the name, carbonate, and notice it has an ATE. So if it has an ATE, you need to change the ending to ic. So this becomes carbonic, and then I throw in the word acid, carbonic acid. Same goes for every other polyatomic ion. So our ion here is nitrate, and that becomes nitric acid. So we're replacing the ATE with the ICE, or IC. This is sulfate, and again, I'm replacing that ATE with IC. If instead it has an ITE instead of an ATE, I think I may have mistakenly use the wrong words at times, ITE turns into us. So if we had the ion SO3, 2-, which is sulfite, so sulfite has ITE, which turns into sulfurous acid. So basically, you look, does it have an A? Then it's an ick. Does it have an I? Then it's an us. Here are some more problems. Why don't you pause the video and give those a try? Okay, did you try them? Let's move on to the next slide. So, SO3 is sulfite, so we have us. So that's ite, and we get an us. CO3 is 8, so we get an ick. PO4 is phosphate, so that's an 8, we get an ick. NO3 is an nitrate, so we get an ick. And this is a chlorate, so again it's an 8, and we get an ick. When writing formula, it's important to first notice, is it binary or does it contain a polyatomic ion? Now remember the different naming formulas we just used. Binary starts with hydro. That's its suffix. Whereas polyatomic uses the suffix of the, well, polyatomic. So I guess the way I think of it is it sort of mentions an element first. So like nitrate or sulfur. So there's some sort of mention of an element that comes first. So you have to figure out, is it binary? Does it have hydro first? Or does it mention an element first? So nitrate, sulfate, carbon, something like that. Then you need to follow the rules for the different formulas. So this is carbonic acid. Because we just talked about it, it starts with the name of an acid, which means it's an oxy acid. So it's polyatomic or oxy acid. We know that it ends in an ick versus an us. And it doesn't start with hydro, so it's definitely polyatomic. So because we know that ick is equal to 8, we know that it's carbonate. So we know carbonate, the formula, if you check your polyatomic ion list, is -2 or 2-. And then we kind of have to balance it out. So if you recall, I told you that compounds want to be equally satisfied. So right now, this 2 is saying that will be it will be receiving 2 electrons from something. Okay, so it's going to be receiving 2 electrons. Well, where are these electrons coming from? And the answer to that is our protons, or our hydrogen ions. So it's going to be receiving 2 electrons, which means we need 2 protons because the hydrogen only have 1 to give away. So our formula becomes H2CO3. Basically, you have to balance out the number of hydrogens with the charge of our polyatomic ion. Okay, I'm going to do one more example with you. Here I have chloric acid. Now, chloric, I'm going to check my polyatomic ions sheet because I know that it's an oxy acid. So I'm going to check my polyatomic ions list for a polyatomic ion that starts with this. After checking, I know that ic, obviously, is 8. Okay, so I have two options. I have chlorate as a polyatomic ion, which is ClO3 minus, or I have chlorite, which is Cl2 minus. So 8 means it's chlorate, which means our formula is ClO3 minus, and we only have one minus, which means to balance out that one minus, we need one plus. And now I'm just going to delete that minus, or get rid of that minus. Okay, so there's that. I'm going to write another one on the screen, and why don't you pause the video and give it a go. Okay, on the screen I have written nitrous acid. Give that a go. Pause the video. First step is figure out if it's binary or oxyacid. Well, I can see that it is an oxyacid because it starts with the name of an element as opposed to hydro. Afterwards, I need to figure out what my polyatomic ion is. So my options are that start with the NITR are nitrate or nitrite. Two different ions. This is NO3 minus, and this is NO2 minus. So because it's an us, I know that it's an ite, okay? That makes my formula NO2, and then I just need to balance out the number of hydrogen ions. So we have one negative electron going to our nitrite, which means we have one hydrogen giving that electron away. And to get the final formula, I just erase the negative. Now, binary acids are the exact same. So let's just say, so we have hydrobromic acid and hydrosulfuric acid. Now, we know that they're binary, so we're going to write our element that's not hydrogen first. So brom means bromine, so that's Br. And we know there's going to be a hydrogen, we just don't know how many. Now bromine has a charge of -1, so one electron would usually be donated. And hydrogen has a charge of +1, so it's a 1-to-1 ratio. We leave it as HBr. Let's move on to the next problem. Pause the video if you want to give it a try yourself. Anyhow, so sulfur, so I'm going to write S, and I know that there's an H, and then sulfur has a charge of -2, and hydrogen has a charge of +1. So to balance that out, I know that I'm going to need 2 hydrogens because we need all of our atoms happy over here. So I'm going to write my 2 over here. And so this is how you name acids. Basically, it's find out what is the other atom, the atom that's not a hydrogen, and then balance out the number of hydrogen atoms needed. Okay, naming bases is the exact same thing as our ionic compounds. I'm not going to talk about them again, because seriously, you already know how to do them. If you want to pause the video and cover up one side of the screen, give it a go. Otherwise, I'm going to move on to the next screen. Writing formulas, you also already know how to do. Practice you can find on one of our many first worksheets, so feel free to go review that if you need. Now for the nitty-gritty of the lesson, neutralization reactions. Okay, a neutralization reaction is a specific type of reaction. So kind of like combustion reactions are a specific type of reaction, so are neutralization reactions. The reactions, or the reactants of the neutralization reactions are an acid, and a base. Doesn't matter which acid, doesn't matter which base, just an acid and a base. So, and they always produce water and a salt. So it's an ionic compound or a salt, always. So an example of that is hydrobromic acid, so there's our acid, plus sodium hydroxide, which is our base, providing us with a water and a salt, or sodium bromide, which is an ionic compound. Remember, ionic compounds have a metal and a nonmetal bonded together. Now, if you remember from last lesson, how can we tell from a formula? So let's write our formula here. Hydrobromic acid plus sodium NaOH gives us H2O plus NaBr. How can we tell from the formulas that this is an acid and this is a base? Pause the video, give it a thought. Can you figure it out? Okay, let's assume you stopped the video. Fun fact, every time I ask you to stop the video, I stop the video, which is just a super weird quirk that I need to get over in these lesson tutorials. But anyhow, so hopefully you remembered that a property of acids is that they have a hydrogen ion, or they ionize into a hydrogen ion, and that bases have a hydroxide ion. Bases are a little bit more complicated because it's not always a hydroxide ion. Check out our last lesson to review that. And then we always get a water and some sort of salt or ionic compound, okay? So always an acid plus a base is equal to a water and a salt. So it neutralizes it. So we're left with water and salt. No more acid, no more base. Well, as long as the ratios are correct. So one thing I want to talk about before we move on is this little symbol right here. So that means aqueous, and aqueous basically just says that this compound is in a solution of water. So you'll see that pretty frequently, and we're not going to get into it, but that's what that means. So neutralization reactions are a double displacement reaction. So they're a specific type of double displacement reaction, and the products of the reaction are neutral because it's salt and water. Well, or an ionic compound. So looking at our reaction, our neutralization reaction, because there's an acid, a base, and it produces water and a salt, you should be able to predict the products, because remember, the products are always a water and a salt. So if I'm writing sulfuric acid, then ic means it's sulfate, so it's SO4, and sulfate has a charge of -2, so I know that I need 2 hydrogens, and I'm going to add that potassium hydroxide, and potassium has a charge of 1, hydroxide has a charge of 1, so we're left with that there, and that goes to water, H2O, plus potassium, KSO4. And because SO4 is 2, then my K gets a 2 as well. So you'll notice that our hydroxide goes into the water, and there's only one hydrogen ion here, but there's 2 here, which means our other hydroxide is coming, or our other hydrogen ion is coming from over there. This leaves our sulfate and our potassium to form the salt. So it's a double displacement reaction, and we're forming water and a salt. So here's another problem. We have our acid, and we have our base, but you'll notice that our base, instead of having a hydroxide, it has a, well, I think your page calls it hydrogen carbonate, but you can also call it a bicarbonate. And so when we have a base that doesn't have a hydroxide, it gives us slightly different products. So our products are still water and a salt, but this time we also have carbon dioxide, because that carbon in our bicarbonate has to go somewhere. So that's pretty much it for this lesson. We talked about naming acids and we talked about neutralization reactions. The next few slides have some uses of neutralization reactions, including things like liming and bee stings, but I'm going to let you take a look at those on your own.